So a couple of words about the history of our company. So we are spun off from MIT in 2001. So the starting point of the company was the development of exothermic technology for the large-scale manufacturing of fullerenes, which has been later extended also to single-wall carbon nanotubes. So the current focus of the company is the large-scale manufacturing of targeted carbonaceous materials. So we manufacture C60, C70, single carbon nanotubes. We define ourselves now as a electronic materials company, basically providing solutions for the printed electronic industry. So we started out with the development and manufacturing of fullerene derivatives as electron acceptor materials for OPV. We are currently active in the clean energy space. We're working on conducting additives, for instance, for batteries. So very briefly, a couple of examples without pointing to specific companies. So how our materials are used, for instance, for indoor OPV, different application, outside OPV, agrivoltaics, mobility, semi-transparency is an important topic. And more recently, we also were active in the space of single junction, but also multi-junction perovskite PV and silicon perovskite tandems. Basically all kinds of tandems. So without entering in any details, let's look on the kinds. We have here on the left side the standard stack of an OPV device, having started out initially by providing electron acceptor materials for bulk heterojunction. So we have progressively extended our activities. We're working in the space of ETLs, on transparent conducting films, for instance, which can be used as top electrodes for an OPV device. And then basically at the beginning of perovskite PV, there came already first requests, so how we can potentially adjust the material, for instance, to improve the bend alignment and things like this. So that's basically the starting point, working first on ETLs for perovskite PV, and more recently we have also an active program on whole transport materials. So very briefly, the manufacturing of fullerenes. So you see here our large-scale industrial reactor on the left side, which can generate multiple hundreds kilograms of C60 and C70. Initially a plant. I will explain briefly how it can be processed. And the picture on the right side, basically you see the downstream processing. Simply in a nutshell, you start with a material which contains about 20%, mainly of the C60 and C70, but also higher fullerenes. They can be simply extracted with an organic solvent. And depending on the target compounds, we have a toolbox of separation technique, for instance, fractionated crystallization and or chromatographic steps, which is largely automated, which allows us then to obtain different mixtures, but most importantly, a standard purity C60 and C70, which can be used in the electronic industry. There's also a relatively high abundance of carbon-84, which is currently not really a commercial product. There's no current commercial application, but I would hope if it's offered on the market, there will be properties which could be of potential interest. So here's the HPLC chromatogram of a blend as extracted. So we see C60, C70, and higher fullerene. So by means of HPLC-MS, we have been seeing up to C116. The absorption spectra, so we see of pure C60, 70, carbon-84, we see this shift of the absorption spectrum to longer wavelengths. That's also the point that the LUMO level of carbon-84 is about 0.3 electron volt below that of C60 and C70, which could lead to potential application, and also the extended absorption spectrum. So we supply blind material. Depending on the application, there's need to do it or not. It really depends